Hello, my name is Ann Purvis. I am one of the leaders of the Toronto Field Naturalist Juniors program. This is the slideshow from the second week of our 10-week nature class, which began September 30th and goes until the first week of December. There's still room in the class, and we'd be delighted if anyone would like to join. This slideshow opens with some photos submitted by Pamela and Amara of some nature art that they created on a hike they were on in the last couple of weeks. I thought this was really great since we did nature art this week in our second week of our nature class. A beautiful heart made of pine cones. So last week in our nature class, Sebastian noticed these balls on the hackberry leaves that we were looking at and wondered what they were. These are hackberry nipple galls. Out of these galls, in the next little while, September or October, comes an adult psyllid fly. So the psyllid fly is a tiny little fly that looks like a miniature cicada. It has long, clear wings that extend beyond its abdomen. This is the adult. The adult female is going to hide in crevices wherever it can for the winter. It tries to get into houses. If somebody has a hackberry tree in their front yard, it will try to get into the house to spend the winter. They are completely harmless, and there's no problem if they do. When they come out of hibernation in the spring, they will lay eggs on the newly emerging hackberry leaves. It's very important that they get the timing right, because what they're going to do is lay the eggs and then inject some saliva into the leaf, which acts like a growth hormone and causes the leaf to grow this ball around the egg. When the larva hatches out of the egg, it has a perfect little environment to spend the summer sucking on the juices of the hackberry. I put these leaves in a peanut butter jar, clear peanut butter jar, to watch because I'd like to see the psyllid fly when it comes out. These are some red oak galls that were photographed by Marina and Sonia and Mila. These were probably created by a cinnipid wasp. So this is a completely different type of insect from the psyllid fly, but it has a pretty much identical life story. The adult will emerge from these galls in the next little while, this fall, hibernate for the winter, and then it will lay eggs on the red oak leaves in the spring when the leaves are freshly emerging, also injecting a little bit of saliva as growth hormone to cause the leaf to create these perfect little houses for their eggs to hatch into larvae and eventually become adults. This is maple leaf spindle gall, and this is caused by another creature called a mite, which has 8 legs. It's not even an insect. Mites are the tiniest little creatures that are so small they can live in the pores of our skin. And the mite, again, has a very similar life cycle. The adults will emerge from here in the fall, hibernate for the winter, lay their eggs on the leaf, and inject a little bit of saliva, which will cause the leaf to grow these structures around the egg so that the mite is protected for the summer as it feeds. All of these galls only cause superficial damage to the leaves, and they should never be sprayed or treated to get rid of them. The populations of these insects go up and down every year. Some years there's more of them, some years there's less of them, but these are the kind of creatures that our songbirds are looking for when they're grazing on leaves. They're often grazing around hardwood trees, and these are the kind of little creatures that they can pick up to eat. So anybody that sees galls, it would be quite fascinating to do what I did, just stick the leaves in a clear jar and watch the creatures emerge. So Nick Pilar was one of our leaders who was helping out our program when we were allowed to have in-person events. Nick has been a naturalist at Awenda Park this summer and is still up there doing some distance university at the same time. He sent us these photos of bear's head tooth fungus. We've seen so many other fungi this fall. we've seen fungi with gills, we've seen fungi with pores, and now we're seeing fungi with teeth. And all of these structures are for bearing the spores, which produce the next generation of hyphae and eventually the next generation of fungi. So tooth fungus comes in all different configurations, as you can well imagine. Sometimes they're mushrooms with teeth hanging down instead of gills. Sometimes they're bracket fungus growing on a tree. So Nick also sent this amazing photo of a netted stinkhorn fungus. This fungus starts out looking a lot like a puffball and is actually in the puffball family. Eventually this stalk emerges from the puffball and produces this head, which is covered with a slime that has green spores in it and stinks like rotting meat. So it attracts flies, which get covered with the goo and the spores, and then they fly away and cause the fungus to grow in other places. So Pamela and Amara found these deer tracks, and they're fascinating for a couple of reasons. We can tell that the deer is walking on its toes because of how heavy these are at the front. I'm sure a lot of us have noticed this before. But also, the deer tracks are in a straight line, and this is a strange thing when you think of a four-footed creature walking in a straight line. And the way they do it is that they bring the back right leg up and plant it in the footprint of the front left leg, and then they do the other side, and it ends up being a straight line track. So Pamela and Amara also photographed this flat-backed millipede. Milla means 1,000, and you would think, okay, they must have either 1,000 legs or 1,000 body parts. Neither is true. The flat-backed millipede, we counted up during the class, has 20 body segments. The reason it's called a millipede and not a centipede is because each segment has 2 legs rather than just one. It is vegetarian and eats decaying vegetation in gardens and soils and mildew, and so it's actually a very important part of the ecosystem, turning things back into soil. This is a cross orb weaver spider that Nick sent us a picture of. It was creating its web in the office window where he works at Awenda. So the cross orb weaver female is going to lay about 200 eggs inside an egg sac attached to her web, and then she's going to die. All of us will remember this from Charlotte's Web. This is the fate of female spiders. And those 200 little spiders are going to hatch out in the spring and have to fend for themselves. So we had fun trying to find the creature that was being photographed here. And I'll just leave that for other folk looking at the blog to see if they can find it. This is a hickory tussock moth caterpillar, which feeds on various hardwoods, hickory and basswood. In the fall, it drops to the ground and forms a woolly cocoon in the leaf litter, and it will spend the winter in the leaf litter. And this is actually a little lesson to us to not be too quick to rake up leaf litter, because it could have these kinds of creatures in it overwintering. And how important is it that they be allowed to emerge in the spring and become adults. This is an ichneumon wasp. And ichneumon wasps are parasitoid wasps. That means that they use this long ovipositor to lay their eggs in the larva of another wasp. So this ichneumon wasp is called Megarhyssa, and Megarhyssa lays its eggs on the larva of horntail wasps. Horntail wasps also have a long ovipositor, which they use to drill a hole in decaying logs and deposit their eggs in there. When the larva hatches out, it starts to dig tunnels and eat the wood inside the log. Megarhyssa senses the vibrations of that larva moving around with her feet, and she drills a hole with her ovipositor to find and seeks to find that larva to lay her eggs on that larva. When her larva hatches out, it will eat the other the horntail larva. So it's quite a fascinating life cycle that these creatures have. And I would advise you to just check the blog for further down. There's a video that we've put up because it's such an amazing way of life. So this, I think, is an underwing moth. We can't see the hind wings here, but they would be colorful. Pretty sure that that's what it is here. And this insect I couldn't find in the insect guide because it was made by my fellow leader and colleague Sandra out of various natural things that she found. And we are going to be doing collages, nature collages, using all different kinds of plant parts. We're excited to get onto that next week.